4E 5N mid-year exam, paper 2016. So for this question, because it says particles in a gas and particles in a solid, when we talk about movement, particles in a gas move rapidly in all directions. And this is another way to explain your answer. Particles in a solid will vibrate and rotate in fixed positions. Or you could simply give this answer as well. For the arrangement, particles are far apart and in a disorderly arrangement for a gas. And for a solid, particles are very closely packed in an orderly arrangement. So this is for question 1. Next, question 2. So this is the question, and they ask you to name the process. So when we see a drop of sample separating out into a few different colors or a few different dyes, this means it's a separation that is called chromatography, also known as paper chromatography. If you turn to the next page, it says how many different dyes are there in the fizzy drink. So if we look at the diagram, this diagram here is not a common diagram. It's using a filter paper for chromatography, but it still works the same way. So we put the drop of sample over here in the center, and it says this is 2 drops of the red solution. So we have placed 2 drops of the red coloring matter on this spot, and we added some solvent so that it can dissolve and it can separate out into the different dyes that are inside. So if you look at it, it has separated out from this point to the first circle. The first circle around it is orange. So orange is our first spot, and then next our second circle that we can see would be pink, followed by yellow and red. So what we have is 4 colors, which is why the answer here says 4 different dyes. Okay, the next part, this is the part that would be slightly more challenging to separate out the students who can score a A1 to perhaps a B3. So for this part C, it says that the experiment is repeated using a strip of filter paper as shown in figure 2.2. This filter paper, this strip of filter paper can also be known as a chromatography paper. And you're supposed to draw and label the positions of the colored spots. So let's take a look at the round filter paper compared to the filter paper that is in a rectangle. So this would be your red coloring matter. This will be your sample. So when the sample separates out, what we see, the first one would be orange. And this is the distance that we have. Okay, so a short distance away, you should draw the spot of orange. Okay, followed by the next color would be pink. And if you notice, the pink color is quite a far distance away from the orange. So then you have a further distance which is pink. And again, a far distance away is yellow. So a certain distance will be yellow. And much closer will be yellow and red. So yellow and red will have to be much closer. So if you, based on what I said, this would be your answer. So you can take a look at orange is pretty near the sample. Pink is pretty far away. Same for yellow to pink, there's quite a big distance in between. But yellow to red is quite a close distance. Okay, and also, since the sample has separated out into the different dyes, there will be no longer any spot on this first line. If there's any spot on this first line, means there was a dye that could not dissolve. So if you look at this answer, there is no more sample spot because they have separated out into the 4 dyes: orange, pink, yellow, and red. So this is question 2C. So how are the 2 marks given? 1 mark for the drawing with the correct distance apart. 2nd mark for the labels, labeling the different color. For the next question, question 3, it talks about a few methods to prepare salts in the lab, and they ask you to complete the following table. So the salts that we have is, first of all, sodium chloride. Sodium chloride starts with sp8, sodium, potassium, ammonium. So since it's a spa salt, the method has to be titration. And because it's titration, we always use an acid and an alkali, or an acid and a soluble base. So here it was given to you, chloride will give us hydrochloric acid, and our alkali will be a metal hydroxide, which is sodium hydroxide. Okay, or the other soluble base is also known as alkali. There is one more, which we call it a metal carbonate. So the other option is using sodium carbonate as well. Okay, but for this question, they have given you the answers over here. Okay, for the next part, copper 2 chloride. It does not start with SPA, but it is a soluble salt because all chlorides are soluble except for silver and lead. So since the soluble salt, not spa, the method is the one where we use an acid and an excess of insoluble substance. So what could the answer be? The acid, chloride, the acid has to be hydrochloric acid. And what is our insoluble substance? It can be a metal, but in this case, copper as a metal is unreactive. So it can be a metal carbonate. So it can also be copper 2 carbonate. So the other possible answer is copper 2 carbonate. Okay, and as for our soluble base, because here says soluble base, okay, insoluble base, sorry, because here says insoluble base, which is why metal carbonate we cannot accept it, but instead we use our metal oxide and our metal hydroxide. So we have to be very careful that it says insoluble base. So therefore our answer is hydrochloric acid for the acid, and for the insoluble base is copper 2 oxide or copper 2 hydroxide. Metal oxides and metal hydroxides are our bases. Okay, next we look at barium sulfate. So barium sulfate is an insoluble salt, which means our method must be precipitation. And based on precipitation, there are two ways to form our barium sulfate. Either, first of all, we use soluble salt and soluble salt, or we use soluble salt and acid. So in this case, sulfate is from sulfuric acid. Barium or soluble salt is barium nitrate. So another possible answer could be still using barium nitrate as the soluble salt, but instead of using sulfuric acid, we use sodium sulfate. Okay, we can also use sodium sulfate and barium nitrate. This is also a possible answer. If you don't want to use sodium sulfate, we can use any other soluble salt that ends with sulfate, like potassium sulfate or ammonium sulfate. So this is your answer for question 3. You need to be very clear on the type of method of preparation, which are 3 types, based on whether the salt is soluble, insoluble, or spa salt. And finally, what are the reactants required to prepare the salt based on the method. Okay, for 3b, it says write an ionic equation including state symbols for the reaction in A part 3. So A part 3, we are forming barium sulfate. As we know, barium sulfate is an insoluble salt. So we have BaSO4 in solid state. So when they say ionic equation, we ask ourselves, what are the ions that can give us barium sulfate? So barium sulfate has the barium ion and the sulfate ion. So barium ion, based on the periodic table, is in group 2, which is where we get Ba2+. Ions must always be in aqueous state. And then we have our sulfate, which is by memory SO4 2-, so also in aqueous state. Then we check if the equation is balanced. So the equation is completely balanced, so that's where you get your 1 mark for balancing equation, 1 mark for not just state symbols but all the correct chemical formulas as well. Okay, for the next page, question 4. Question 4 is a typical QA question. where they give you some a table, okay, and they ask you to figure out what we have. Okay, so now take a look at this first. We have a substance A, and on warming with aqueous sodium hydroxide, give us a salt and a gas. So if you remember this, one way to remember this is to know that sodium hydroxide is our alkali, or also known as base. And this is warming with a base or an alkali, which means it could be a reaction of a base. So when base, what reaction of base needs warming? It is the one with ammonium salt. Okay, so this could be an ammonium salt substance A. But before we go into that, we shall look at this side, because this side is much easier. So this side, when they say warm with aqueous sodium hydroxide, you can remember that it's a cation test. It's a test for ammonium ion. Okay, cation test, adding sodium hydroxide and warming, is a test for cation, ammonium. And if ammonium is present, what we see is ammonia gas is produced. So ammonia gas, if it's produced, you should see a gas, right? So here we see a colorless gas. And how do we test for ammonia gas? We use litmus paper. So what happens here is, instead of testing for ammonia gas, they put the gas in water. That means this gas is soluble in water. And after that, you get a solution which turns your universal indicator blue. So here, universal indicator has a few colors. Universal indicator is red, orange, yellow, green, blue, indigo, violet. Red, orange, yellow is for your acid. Blue, indigo, violet is for your alkali. Green is when it's neutral. So since it's a universal indicator turned blue, which is here, means that this solution is an alkaline solution, which, based on this, the gas that will give us an alkaline solution would be ammonia gas. Ammonia gas dissolving in water will give us ammonium hydroxide. Ammonium hydroxide is a weak alkali that will turn our universal indicator blue. So from this portion over here, we know a few things. We know that first of all, this should be a cation test, which means we are testing for ammonium. And if so, ammonia gas is likely to be produced. Here I have a colorless gas, which means it could likely be ammonia gas, dissolving in water, where we get ammonium hydroxide. And indeed, ammonium hydroxide is a weak alkali that turns universal indicator blue. So now we know that our D is ammonium hydroxide. Okay, and if we move up to A, we know that our A has ammonium ion. So indeed, A is a ammonium salt. Okay, so now we move on. So let's say, how did I get this chloride? Okay, let's look down on this portion here. So here, we know that, let's say our base reacts with ammonium salt. Okay, so here, let's say we know that our base reacts with ammonium salt. What we will get is salt in water, which is an aqueous salt, and we get ammonia gas. Okay, so very likely this is what is happening over here. Our ammonium salt, substance A, reacts with our base on warming to get our aqueous salt and our ammonia gas. But the question is, what is this aqueous salt? So if we look on, this test here is a test for anion, which is chloride. And if chloride is present, it will form a white precipitate scene, which is silver chloride. Silver chloride. So if silver chloride is formed, that is when we know it's a chloride ion. So we see that there is a white precipitate C. So C must be our silver chloride, also known as AgCl. So C must be our silver chloride. So now we know that this aqueous salt must have chloride ion, So if we have a chloride ion in this aqueous salt, this chloride must have came from substance A. So that means ammonium will have ammonium chloride. Okay, ammonium chloride. So now let's test this out. If we know that A is ammonium chloride, so A is ammonium chloride. We have ammonium chloride plus sodium hydroxide. So I'm going to write this one more time. Ammonium chloride, which is our A, reacting with sodium hydroxide here on warming. So this is our base. This is our base. Okay, and this is our ammonium salt. And what are we supposed to get? We're supposed to get a salt, water, and ammonia gas. Okay, so let's write it down onto the top. Ammonium chloride plus sodium hydroxide will give us a salt, water, and ammonia gas. Okay, so if you notice, my ammonium has already been taken out to get my ammonia gas. My hydroxide has been taken out to give me my water. So what am I left with? What is the name of my salt? Name of my salt will always end with chloride. And I need a metal, so my metal is sodium. Sodium chloride. So my aqueous salt B. So B is sodium chloride. Okay, so B is sodium chloride. So based on this chart, you can find your answers where A is ammonium chloride, B is sodium chloride, C is silver chloride, and D is ammonium hydroxide, also known as ammonia solution or aqueous ammonia. So this will be the answer for 4A. So 4A does require you to know your reactions of acid and base. Next, we move on to part B. Write a chemical equation for any of the reactions in the above. So this reaction is based on base plus ammonium salt. This is our very first reaction where we have our base as sodium hydroxide, our ammonium salt is ammonium chloride, forming sodium chloride, water, and ammonia gas. This one here is based on the anion test, where we have our sodium chloride reacting with our silver nitrate. Okay, so these are two soluble salts, giving you an insoluble salt, silver chloride, giving you an insoluble salt, silver chloride, and another soluble salt. So here was my anion test. It is soluble salt plus soluble salt, giving you my insoluble salt, which is my PPT, and my soluble salt. So my PPT here is my silver chloride. So this is the second equation. Okay. And the final equation is talking about ammonia dissolving in water to get ammonium hydroxide. Okay, so preferably the first two is a better choice to write a chemical equation.